Okay, so the last part is on real-time test and tuning used for prototype or the massive production filter tuning lines. So our current function integrates the Rohde Schwarz, ZNB, ZND, and ZNL series of vector network analyzer. So let's check out the function one by one. The first one is the OneBarton connection and analysis setup. With the proper IP address setup, it allows user to connect with the VNA with OneBarton clicks. Additionally, all the relevant parameters regarding to the test and tuning work, for example, the start-stop frequency, sweep point, and the bandwidth, average power, will be set up automatically. The second one is the tuning mode. Different as other tuning software, SynMatrix provides two modes for test and tuning purpose, streaming mode and the manual mode. Streaming mode can be used for mature product on the real-time test and tuning work, so the end user can apply it for the massive production tuning line. Well, the manual mode used for prototype diagnosis purpose and allow user to tune and identify the issue step by step. To provide the best user experiences through the SynMatrix platform, then the user can fully control the VNA without touching any button. For example, they can set the different diagrams with adding or deleting different measurement curves. The measurement format such as the magnitude in dB, phase VSWR with the proper scale values will be easily switched. Additionally, user can set up the marker and the specification line by simply click on the plot. So all these parameters can be passed to the VNA and set up immediately. Okay, so for some very special application, especially for case with very low notch level, SynMatrix provides the smooth curve function to smooth out the noise. It can enhance the diagnosis accurately. So after the tuning work, user can export the test report with the different format and record the tuning notes used for further massive production tuning line. So then we will jump to the test and tuning demos.
Hello everyone, so welcome back. I will continue with the previous part to give you the demonstration on this test and tuning part. Okay, so here this is the 10-pole coaxial cavity filters. The specification is on the screen. Central frequency is 3.5 GHz with 1 GHz design bandwidth. So we have the 30% fracture bandwidth. No doubt this is one band applications. So outside the band edge, about 205 MHz from each band edge side, it has 40 dB rejection levels. Okay, so on the right side, this is Rohde Schwarz ZNB model vector network analyzers. So this model has a really powerful functions. So it has a really wide range frequency range, starting from the 9 kHz to 8.5 GHz, with a dynamic range can be up to 140 dB. And also it has a very short sweep time, about 4 microseconds for 401 points. Okay, so later I will use this VNA to demonstrate to you how to use the SynMatrix software to tune these filters. As you can see, we used the Ethernet cable to connect my laptop with these ZNB models. And also, as I mentioned before, so user need to set up the IP address properly, and then it will connect with each other easily. So user can find all the support materials in our e-libraries functions, including how to do the synthesize, how to do the computer-aided tuning, as well as the AI part, and also how to connect these VNAs. Okay, let's check it out.
Okay, so the first step, user need to log into our system. So user can register the account in our website, and also this test tuning package need a special apps, and user need to install in their computers. So if you're interested in this package, you can send our email through the support@synmatrixtech.com. Okay, so firstly, user need to import their username and password to log into our system.
Okay, once you onboarding, user need to load up their design project because this project is previous design well designed. So user needs to go to the project management and find the proper project. We call the test and tuning case 10-pole cavity filters. So user can load it up. Okay, so as you can see, all previous designed matrix, the S parameters, as well as the markers, it can be shown up here. Okay, I just give you a very brief introduction on these GUIs. So firstly, user need to define their filter orders and the return loss, center frequency bandwidth, and also the proper and loaded queue here. So once they design it, they can add the transmission zeros, just depend on their specifications. Okay, we have two formats. One is for gigahertz, which is on the real frequency. Another one is for the normalized frequencies. Okay, so and also user can define the complex the transmission zero as well. Okay, so once you have the transmission zero input, if necessary, user can define their topologies. So user can just easily check the box to define their topologies. So okay, so for this case, we are very simple topologies. It's a pure chip shift filter designs. Okay, once you have everything, you can click calculate all, and all the matrix and the relevant S parameters will be returned from our server and displayed in the panels. Users still can check their good delay and also the stored energy curves for each one. You can click up, as you can see here, to select the different resonators to see the curves changes. Okay, and here users still can define their the materials. So for this case, we use aluminum, and the operational temperature is from the minus 30 to 80 degrees C. And based on this temperature range, we get the thermal drift value is about 4.4. This is just coming from the mathematical analysis. So as you can see, this is the specifications. So I will show up here. So for this left and the right the margins, that means if you have the enough margin to compensate these thermal drift values. If this values is higher than this thermal drift value, it will show the greens and also show the parse. Okay, so user can define the specification as they want. So okay. And also for these coupling matrix functions, user can edit their coupling matrix values and also export the matrix and also the S2P file, and also they can upload their designed matrix. This is customized matrix as well. We will return the corresponding S2P file, and also they can edit their signs, which means they can change this the positive value to the negative values. Correspondingly, in the structure, the angles, if you change it to the negative values, so the coupling probably will change from the magnetic to the capacitives. Okay. Of course, here this is the filter dispersion control effect. So it will use for the phase distort case, especially for the one band application, such as this case. Okay, because this is really one band applications, it will require that every the coaxial resonator has a really strong couplings between each other. Of course, this belongs to the magnetic couplings. So usually just a higher side will rise up. So we just give some experience numbers as 0.2. As you can see, if you just put in zeros, apply this one, user will be able to see almost a symmetrical the effect for these S2P files. So when they add it to maybe 0.5, people can clearly see the higher side will rise up. So of course, correspondingly, you will lose the margins at the higher side. Okay, so for this case, we design as 0.2. Okay, so after this bandpass filter design package, so users still have the diplexers and the triplexers designs. So user need to define each band filter informations and also click the calculate all. So it will return the corresponding matrix and also the as parameters. Users still can go to the overview page to overview all the performance here, such as group delay, as parameters, and power handling, the store energy curves. Yeah, if you want to design the triplexers, you need to add the third page. Okay, so let's go back to the test and the tuning part. So by the way, under the optimization part, so this is called the computer-aided tunings. So here, I mentioned before, we have three major coupling matrix extraction method, and here this is the intelligent tuning part, which integrate Ansys HFSS the APIs. It can run automatically all the customizations. Okay, so let's go to the filter tuning part. Okay, so when user go to the filter tuning page, all the previous parameters, I mean the filter information, will be passed from the synthesize page to this page. For example, like the coupling matrix and as parameters, as well as these specifications. So, okay. Of course, the first step, user needs to connect with the VNAs, as I mentioned. So user can go to the e-library to find the proper technical support. It will show how to connect with SynMatrix, between the SynMatrix and the vector analyzers. Okay, so first one, user need to call the calibration files. Okay, so we can pick up the calibration file. It's a demo 2 to 5G. Okay, as I mentioned, all the parameters will be passed, so user doesn't need to worry about how to set up the frequency, like the start-stop frequency and the sweep point bandwidth. So all parameters can be embedded automatically. Okay, so once connected, user will be able to see the VNA changes. Okay, and initially we will get the data from the VNA and show up here. Okay, so I will introduce something starting from the tuning settings. Tuning settings will show the tuning informations in the arrows to show user need to screen in or screw out. Okay, and here this is the trace informations. User can somehow control the vector network analyzers. For example, you can add the trace, right? And we can have the separate diagrams. For example, the diagram 2. Okay, we can define the as parameters as S11 and also add another one in these diagrams called S21s. So right now we have the magnitude in dB, and also we can show the phase. See, this is the phase for S11. Of course, the user can show the VSWRs, and also we can change the scale to 0.1 to get more details. Because the VSWR now is too bad, so set up 2 and maybe 4. Yeah, as you can see, user can easily set up these scale numbers here. Okay, so fully control the VNAs. Okay, and here the markers. For this marker, user can easily click the point on this screen. As you can see here, all the information will be passed to the VNAs and sync up together. So it's very convenient to use. If you want to edit the specific frequency, just click it and click markers, and then you can add the markers. Okay, so and here just delete everything to give the very clean screens. Okay, and once they finish the test tuning part, they can export the report. So I will show this function later. And also they can smooth the curves. Okay, yeah, they can smooth the curves, and also we have smooth factors 3, 5, and 7. The higher values we smooth out more the noise. Okay, this is function used for very special case with the very lower notch levels. Okay, so let's start the tuning work.
as I mentioned, we have two modes. The first one is a streaming mode, and here is the manual mode. We can start from the manual mode, okay? So when you click the extract matrix, okay, we will extract out the coupling matrix error informations here. So all the bars represent either the frequency information or the coupling informations. On the head of each bars, user can see the tuning informations like the in or out. So which means you need screw in or screw out. We have two different formats, coupling bandwidth and absolute coupling error informations. So here we use a coupling bandwidth convert to the frequency informations. Okay, and also we can freeze on. Freeze on, that means we'll record the previous result. So user can easily cross comparing your current result versus your previous result. Okay, so user can tune these errors starting from the biggest errors. For example, I just tuned M33 or M99. Okay, so M33 it shows just in. Okay. M99 still in. Okay, and after you done something, you just click the extract matrix. Okay. Okay, as you can see, it's improved. Okay, another thing that I need to mention is user can define a capture range from to. So the best result, in order to get the best result, so user need to capture the range close to the band edge. So for example, I defined here is maybe 2.95 gigahertz to 4.45 and set it. If you leave it at zeros, so our system can detect the best range by ourselves. Okay, so we can continue on this one, M77 and M99. So M77 still screw in and M99 screw in. Okay, after that one, just click the extract matrix. Okay, it's getting better. You can see the error is just dropping. And another thing worth to mention is user can focus on the text colors. As long as the color changes green, that means your tuning in progresses. If it changes red, that means your current one, the current error is higher than the previous one. Okay. Okay. So yeah, and then probably the next step we will go to the streaming mode. And also to proceed the streaming mode, in the specification page, we can activate the specifications. So just on and import. Can go to the bandpass page to refresh everything, and here to import everything and refresh it. So user will be able to see all the specification lines will be signed up to sync up with the VNAs. Okay, we can base on this field path information to tune these filters. Okay, so and at this case, I will just narrow down the capture ranges a little bit and click set. And also in the meantime, user can define the start, stop frequency, sway point, and the bandwidth, and also the average powers as well. Okay, so let's start its tuning work. Okay, and also I just click the freeze on. So just start tuning from 22 M33 and 22 M33 in. Okay, M33 in. Okay. As you can see, the light red, that means the previous memory result, and the dark red, that means your current result. So from the green colors, user can see the error is in progresses. Okay, so let's change to the M44. M44 is out. Okay, it's in progresses. Maybe over a little bit, and we can take care later. So, and M55. In a little bit. Okay, M8, M7 in a little bit. Yeah, okay. So as you can see, we almost have the filter shapes. So it just keep tuning on these frequency informations, because after the assembly work, probably the most critical part for the filter performance is the frequencies. So user need to figure out the frequency firstly, and then focus on the coupling informations. Starting from the frequency still in, and here in, so in. In. Okay, we'll shift the frequencies a little bit step by step. Okay, it's getting progresses. As you can see, for several steps, we'll almost get these filter shapes. And then the next step, probably just fine tune a little bit, step by step. And eventually you will get to the perfect result. Okay, and during the tuning work, user may keep changing this the capture ranges to closer to the band edge. So it will give user the best the extraction performance, and also, okay.
Okay, because we have the limited time on this workshop, and here I only show the final result to you guys. I don't fully record the whole tuning process. As you can see, only about the 10 minutes I can fully tune these filters. With the return loss, the whole band is lower than -21, and we have very pretty curves here. Okay, thanks for watching, and hope you guys have a good day.
Okay, so the slides presentation stop here. Thanks for all your attention. If you are interested in our software, you can contact us through info@synmatrixtech.com or ask for technical support through the support@synmatrix.com. Our user can follow us through the LinkedIn, YouTube, and Twitter channels.